Hello everyone, my name is Vitaliia-Anna Oliinyk, and today I will be presenting you my project that concerns the text and propaganda in text data. We'll start off with a simple definition of propaganda and why it is important that we recognize it. This issue is more pressing today than it was a few centuries ago, due to the fact that it's easier to access information, to produce it, therefore making it more easy to shape and distort it and make it more subjective. Subjectivity is one thing, it can be accidental, whereas propaganda is a deliberate spread of ideas designed to influence an audience in some way and further one's party agenda, often at the expense of an opposing cause. It can be performed simply by using fake news and misinformation, by stating things that are simply not true, but it can also be much subtler than that and use various techniques that make it more challenging to recognize it when someone encounters it. A few examples of propaganda techniques are red herring. It's a concept of introducing an irrelevant material to the issue being discussed to divert attention from that issue. Also, straw man. It's when opponent's position is substituted with a similar one, although not exactly the same. Also, a bandwagon. It's an attempt to persuade audience to join in and take this certain course of action because everyone else is taking the same action, even though it may not be true. It's also not uncommon to encounter loaded language in propagandistic texts. It means that the text will use specific words and phrases with strong emotional implications to influence the audience in some way. Also, these texts often tend to exaggerate or minimize. It means that they are either representing something in an excessive manner or make something seem less important. Also, propaganda often appeals to fear or prejudice of its target audience, seeking to build support for an idea by instilling anxiety or based on preconceived judgments. It's not a complete list of propaganda techniques, but these are the ones that are more frequently used. So, political propaganda in media poses a very important issue for the current social and political climate, causing misinformation and misleading the public. Currently, propaganda detection is being performed manually with the use of statistical analysis by trained professionals, although this process is very resourceful and slow. So the goal of this project is to build a system based on the supervised machine learning algorithm trained to automatically detect propaganda in text data on a document and sentence level. Although this objective is not new and quite a few researchers in this field have been conducted. Next, we'll discuss and review some of the already conducted researches in this field. The first system we'll be reviewing is framing and agenda setting in Russian news. This research is primarily conducted with regard to what is called an agenda setting and framing techniques, that is, what topics to cover and how to cover them. It focuses on the Russian newspaper Izvestia and how it uses its news coverage of the US to distract the public from negative economic events in Russia. It uses structured topic modeling to capture frames, like a reader might conceptualize them with the help of previously formed framing lexicons in the context of politics, public sentiment, external regulation and reputation, morality, and fairness and equality contexts. Some of the advantages of this system include detailed analysis of the topics covered, a very complex approach to framing lexicons, and the fact that system detects framing and agenda setting within the context of the data, making the model more precise in terms of general political climate. Also, although this contextuality is also the main disadvantage of the system, because in order to use model for more general patterns, the appropriate data must be acquired. That means that without providing the context of the data, we can successfully determine its nature. Also, the second disadvantage is the fact that research focuses primarily on framing and doesn't take into account other propaganda techniques. Second system focuses on locating frames in the press. This research is also centered around framing of the certain topics in press. It uses SVM, support vector machine, for modeling. SVM is considered a very popular model when it comes to text classification, as long as the classes are linearly separable. It suffices to find a hyperplane that allows to separate sets from one another. The system is built on top of the Spanish press dataset, focusing on the news of year 2015. The main advantage of the system is the fact that SPM model is very efficient in the task of text classification if the data is linearly separable, and this system uses more general approach than in the previous example. The main disadvantage, of course, is the fact that SPM model wouldn't be very efficient when data is not linearly separable, and like with previous example, this system covers only the aspect of framing of the propaganda, and it takes a lot of manual data analysis and feature engineering to tune in the model to the particular data. The third system is a project called FakeCrunch by Ukrainian data platform Text.org. It functions in the form of the browser extension as well as a chatbot. It takes the link to the news source as the input and produces an output in the form of text, indicating whether the source contains propaganda or some sort of information manipulation or not. It uses transfer learning as the base. It means that it's taken an already pre-trained model, potentially even trained for a completely different task, then uses it for the originally needed task. And instead of using labeled data and then training model for classification, FakeCrunch uses clustering instead. The main advantage of the system is the use of transfer learning. The model needs less data to be trained for the specific task, and the clustering approach relieves from the process of data labeling. Also, the deployment of system in the form of web extension and chatbot makes it easy to access and use it. Although a lot of computational resources are needed to implement that specific architecture, and model can be less specific as a result from transfer learning. So, two of the three aforementioned systems focus primarily on framing and agenda setting techniques, but sometimes it's not enough to detect information manipulation that's being performed by the source. The third system, however, focuses on the more detailed approach and functions rather efficiently, but doesn't provide a detailed output, and as a result of its work can be somewhat high cost computation-wise. The goal of this project is to develop a system that can be applied to more general text data, and with any luck provide a more detailed analysis as an output. So next we'll discuss the approach to the problem. That means tools and means we'll be using to implement the project. We'll start off with the data description. So the goal of this project is to try and analyze text data both on documents and on the sentence level. For this, I will be using two separate datasets, one for the document level and one for the sentence level. The document level dataset consists of 60,000 news articles annotated as either propagandistic or not propagandistic, as well as a unique identifier for each article in the dataset is provided. A sentence-level dataset consists of 451 news articles with sentence-level annotations. It means whether it contains propaganda or not, as well as unique identifier for each article and sentence in the scope of the article. For feature engineering, we'll be using part of speech tagging, text blob for subjectivity and polarity estimation, TF-IDF algorithm for that being used for vectorize our data, and for semantic extraction we'll be using stemming and word embeddings. I've considered a lot of potential candidates to use in this particular project, including SPM, naive bias, and decision trees. But I've decided to go with this project with linear regression for the document level detection and a random forest model for the sentence level detection. Due to the fact that we could not guarantee that our data will be linearly separable, so SPM may not be the most efficient model to use in this approach, and naive bias and decision trees usually poorly perform with few parameters. The main programming language I will be using for this project is Python, due to it being more general purpose language that will make future model deployment much more easy. And as for IDEA, I will be using Anaconda distribution and more specifically Jupyter. The libraries and packages I'll be using include NLTK for NLP tasks, scikit-learn, pandas, numpy, textblock, and matplotlib for the visualization. The important part of the model is how we are going to evaluate it, how efficiently it performs. So the metrics I'm going to use is F1 score and precision. These are the common metrics that are being used in the tasks of classification. And that concludes my presentation. Thank you for your attention.